Welcome back to part 4 of 8th grade geometry standard number 3. Our goal for this video lesson is to describe the effect of dilations on coordinates. So using coordinate notation, how does a dilation affect the coordinates? This is our first video where we will not be talking about a rigid motion. All of these other videos that you've seen so far for translate, rotate, and reflect, those have all been rigid motions where the shape stays the same size and same shape. So the shapes are congruent, the pre-image and the image are congruent. This is the first time we will be seeing our pre-image change size. And so a dilation is when a shape grows or shrinks. And I've got some examples down here at the bottom. I can see in this first one, my original shape, my pre-image triangle ABC, is growing into triangle A prime, B prime, C prime. So that is a dilation. And that's kind of the one that most people think of with a dilation. We think of something growing. But a dilation is also when something shrinks. So this is parallelogram A, B, C, D, and I can see that the size is now smaller, A prime, B prime, C prime, D prime, and this is also a dilation even though it's shrinking, and we're going to be using the scholar words enlargement and reduction. So this is an example of an enlargement, this is an example of a reduction. And we need 3 things in order to perform a translation. And if you've seen the other videos, you probably know that the first thing that we need is a pre-image. The second thing that we need, which we'll talk about more in a moment, is a scale factor. The scale factor is going to tell us how much we are growing, how much we are shrinking, or to use the scholar words, it will tell us how much we are enlarging our shape or reducing our shape. We also need a center of dilation. And these 2 examples here showing a center of dilation that looks like it's probably at the origin, which is 0, 0, but we can use any point as a center of dilation. So to talk about scale factor, which is going to decide how our shape is enlarging or reducing, the first thing is I want you to think about what happens when you multiply any number by 0. So for example, if you did 5 multiplied by 0, we would get the answer 0. So that would make our shape disappear. So we won't use a factor, a scale factor of 0, because that would make our shape disappear. What happens if you multiply a number by 1? So again, for example, 5 multiplied by 1. 5 multiplied by 1 is 5. So if I started with a 5 and I ended with a 5, my shape hasn't changed size. So if our scale factor was 1, the shape would stay the same size. So we need to think about how I could take a number like 5 and make it larger. What could I multiply 5 by that would make it larger than when I started? And so the most common response is, well, you could multiply by 2. Yeah, I could. 5 multiplied by 2 would give me 10. That would be larger. That would be doubling. Or 3, for example, that would be tripling the size. I can multiply by anything that is greater than 1. So even something like 1.5 would cause an enlargement because it's greater than 1. If I multiply 5 by 1.5, I'm going to end up with a number that is greater than 5. That's an enlargement. I could also multiply by a fraction, just 3 over 2, which is also 1.5, is greater than 1. It would cause an enlargement. So I want to make sure that we understand that we don't have to multiply by whole numbers. Anything greater than 1 is going to cause an enlargement. So if something greater than 1 is going to cause an enlargement, something less than 1 is going to cause a reduction. We need to be a little bit careful here because -4, for example, is less than 1. And so I've got a little note down here. Can a scale factor be negative? No, because we're talking about shapes. And if one side of my triangle is 2 centimeters and I multiply 2 centimeters by a scale factor of -4, I can't get a length of -8 centimeters. It's not possible to have negative lengths. So when we're talking about creating a shape that is getting smaller, a reduction, my scale factor needs to be less than 1, but also greater than 0. So we're talking about numbers that are between 0 and 1. Well, what kind of numbers are between 0 and 1? Fractions and decimals? Yeah, so a scale factor of 1/2 or 5/10, which are the same, that would cause my shape to be half as large as it was before. A scale factor of 25/100, which is the same as 1/4, that would also cause my shape to reduce, to be smaller. It would be 1/4 of the size. And so that brings us to the last point here about scale factors, is that we are always going to be multiplying when we're talking about a scale factor. And so I need to figure this out because I think of making something smaller, I want to use division. But divide by 2 is the same thing as multiply by 1/2. So 10 divided by 2 is 5, and 10 times 1/2 is 5. Those are the same things. So my scale factor, if I wanted my shape to be divided by 2, half as large, I would multiply by 1/2. And so the same thing is true for dividing by 3. Dividing by 3 is the same thing as multiplying by 1/3. And dividing by 4 is the same thing as multiplying by 1/4. So let's go ahead and try a dilation. Here's my first example. We need 3 things. Pre-image, I see this here, triangle X, Y, Z. We need a scale factor, and for this example, we are going to use a scale factor of 1/2. So, is a scale factor of 1/2 going to cause an enlargement or a reduction? Well, since it is less than 1 and greater than 0, I can tell that this is going to cause a reduction. My shape is going to be half as large as it was before. And so the way that we show a reduction with coordinate notation, if our center of dilation is 0, 0, the origin, we're going to simply multiply our x coordinates and our y coordinates by the scale factor. So we're going to multiply our x coordinate by 1/2. We're going to multiply our y coordinates by 1/2. So half of -4 is -2, and half of 2 is 1. So my new x, called x prime, will be located at -2, 1. And I'll label it x prime. And my y, half of 6 is 3, and half of 0 is 0. My new y, called y prime, will be located at 3, 0, and I'll immediately label it y prime. And my final point, z, half of -2 is -1, and half of -4 is -2. My new z, called z prime, will be located at -1, -2. And I'll label that z prime. And when I connect my 3 points, I see that I have a smaller triangle than I started with. Okay, it has indeed been reduced in size. It's a reduction. So is my pre-image congruent to my image? Okay, it is not congruent. Congruent means it's the same shape and the same size. So when we do a dilation, we will end up with an image that is not congruent, but instead similar. And there is a follow-up video to this about similar shapes and similarity. This is the symbol for similar. You actually notice it right here at the top of our congruent symbol. But these are not congruent. That's why we have to get rid of the congruent symbol. They are not equal, but they are similar. So we can also have a dilation that has a scale factor larger than 1. So for this one, we're going to do a scale factor of 3. And this will cause an enlargement or a reduction. Because it's greater than 1, and I just think back to my number 5, if I do 5 times 3, I get 15. It's larger than it was before. This is going to be an enlargement. And the way that we show this in coordinate notation is we take that scale factor and we're going to multiply our x coordinates by 3 and our y coordinates by 3. So I'm going to do the first few of these, and I would like you to finish the last 2 and then complete all 4 points and connect the dots so that you have quadrilateral M prime, N prime, O prime, P prime. So my original point M, if I multiply the x coordinate 1 times 3, I will get 3. If I multiply the y coordinate 3 by 3, I will get 9. So M prime, N prime is going to be located at 3, 9, which is all the way here at the top, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll immediately label it M prime. My new coordinate N, 3 times 3 gives me 9. 2 times 3 gives me 6. My new N, called N prime, will be located at 9, 6. 1, 2, 3, 4, 5, 6. And I'll immediately label it N prime. I would like you to please finish finding the locations of O prime and P prime, connect all 4 points to form your quadrilateral, and we should notice then that our new shape is not congruent. Our pre-image and image are not congruent to each other. They are not the same size, but they are the same shape. The same shape, but not the same size. My pre-image and my image will be similar, but not congruent. So both of these examples, we did the center of dilation at the origin. For this final example, we are going to dilate from a point. So for this final example, we are going to use point Q, which is this point right here, as our center of dilation. And I'm going to use a scale factor of 1/2 again, and 1/2 is going to cause my triangle to be reduced in size. It's going to shrink. And so when we are going from a point not on the origin, I don't have coordinate notation down here to fill in, like we did in the other examples, but instead I'm going to take a look at the lengths. And so I see that this original length QR had a distance of 2. Well, half of 2 is 1. So my new distance is going to only be a distance of 1. My new R is going to be right here, and I will call it R prime. Only has a distance of 1 instead of 2. When I look at my original side QS, I see that it had a distance of 1, 2, 3, 4, and half of 4 is 2. So I will go a distance of 2, and that is where I will find my new S, which I will call S prime. And if I connect those 2 points, I can see that I have a triangle that is 1/2 the size that it was previously. So I can see that S prime is located at 1, -4, and R prime is located at 2, -2. What about Q prime? Q prime is actually in the same location as Q. That was where we were dilating from. That was our center of dilation. So Q prime is actually in the same location that it was before.